Hello everyone, I'm Rhianna-lily Smith from Technology Networks, and today I'm delighted to be joined by Dr. Rohit Ramchandra, an Associate Professor from the University of Auckland, New Zealand, to discuss their latest study published in Circulation Research. Ramchandra and his colleagues discovered a novel function for the vagus nerve in exercise that contradicts previous beliefs. Can you talk about what we know about the role of vagal activity in the body?
Um, in terms of what we know about the role of vagal nerves in the body, we know that the vagal nerves innervate pretty much every organ in the body. They include both so-called afferent nerves that receive information from organs such as the heart, the kidney, the gut, and send this information back up to the brain, as well as efferent nerves that release neuromediators, neuromodulators that can essentially alter organ function. The vagus nerve is referred to as the rest and digest system. It's a little bit of a shame because it implies that it's only active during rest and digest conditions. But actually, we now know that both the sympathetic as well as the parasympathetic or the vagus system are active during a lot of different conditions.
What inspired your team to explore the role of the vagus nerve in exercise, given its traditionally assumed inactive status during physical activity?
In terms of why we were interested in the role of the vagus and really the cardiac vagus branch, so the vagus branch of the heart and exercise, is because the traditional view was that during exercise, sympathetic activity is elevated, whereas vagal activity is diminished. But really, this came from a number of assumptions that we now know to be not true. People have kind of used changes in heart rate as evidence of what the vagus nerve might be doing, but we know that the vagus nerve does more than just affect heart rate. It can affect contractility of the heart, it can alter blood flow into the heart, etc. Um,
Could you elaborate on the specific methods and technologies used to monitor cardiac vagal nerve activity in exercising sheep? And why was sheep chosen as the model for this study?
there have been a number of studies, a number of good ones in the last 10 years, but also there have been a smattering of studies for the last 20, 25 years that have all kind of questioned this idea that the vagus nerve might not be active during exercise. One of the issues with the majority of these studies is that a lot of them were done in direct preparations. And so we want to test the hypothesis by directly measuring from the cardiac vagus branch. Doing this is quite difficult in rodent models and obviously impossible because it's too invasive in humans. And that's what led us to use large animal models, such as the sheep model, to try and interrogate this question. We had a lot of expertise in recording from sympathetic nerves to the heart and the kidney, for example. And so we kind of want to challenge ourselves and go, can we do this for the cardiac vagal branch going to the heart? And what we showed was actually when we directly record from this cardiac vagus nerve, and we used a number of tests to kind of convince ourselves that the nerve that we're recording from actually goes to the heart as well as influences organ function. And we showed that actually there's an increase in activity to the heart during exercise, and that this increase in activity actually does something, and it kind of helps improve blood flow to the heart. So when we directly recorded coronary blood flow, we saw that the cardiac vagus nerve was responsible for the increase in blood flow. And importantly, it did this not using the traditional neuromediator, which is acetylcholine, but did it via this secondary, if you like, neuromediator, which is vasoactive intestinal peptide.
The study challenges the historical assumption about the sympathetic nervous system dominating during exercise. What implications might this discovery have for our understanding of human physiology, and how might it influence future research in this field?
Given that our data, together with a number of others, have now suggested that there might be co-activation of both sympathetic as well as vagus activity to the heart during exercise, I think this has a number of implications. Broadly speaking, I think there's this assumption that the sympathetic and the vagus nerve, especially in terms of heart rate control, is a one or the other phenomenon or a yin and yang phenomenon. And I think hopefully this allows us to kind of get rid of that phenomenon and go, there are a number of reflexes. And indeed, if you look at the literature, uh, with the exception of one or two reflexes, in a number of situations, you can have coactivation of both the sympathetic and vagal activity to the heart. And I guess the future research is going to try to determine why we have these coactivation and what influence does that have on organ function or really heart function.
What challenges exist when studying the role of the vagus nerve?
One of the challenges that exist with studying the role of the vagus nerve is that it's a very mixed nerve. So it contains nerves that both go to the organ to affect organ function, as well as relaying information from the organ back to the brain. But also depending on where you study it, it can be incredibly mixed. And trying to get specificity in terms of going, we want to record from nerves that only receive or pass information to a specific organ is one of the challenges, but also trying to separate whether it's information going to the organ versus coming from the organ is difficult, but there are a number of groups kind of working with that.
We are continuously learning more about the vagus nerve. What implications do you see these findings having on the future of medicine, for example, in the treatment of human disorders?
In terms of what are the implications of this finding, my research group is really interested in trying to target this altered autonomic function during a number of cardiovascular pathologies, and one of our particular interests is in heart failure. We know that in patients with heart failure, there is an elevation in sympathetic drive to the heart, and we think there is a reduction in vagal drive to the heart. It is pharmacologically a little bit easier to block this elevation in sympathetic drive, which we do with beta blockers, which really improve outcomes in patients with heart failure. But trying to elevate something that suppresses is a little bit more difficult. We do have ways to try and activate cardiac vagal activity with a number of devices. But one of the challenges is trying to kind of get back to that specificity. How do we know that we can selectively activate vagal activity just to the heart, which is our interest in cardiovascular disease, and not affecting it to the other organs? And there are a number of research groups that are really trying to focus on how we can get specificity and hopefully to try and improve outcomes in patients with heart failure, but also along the line to perhaps improve exercise tolerance, and quality of life in these patients with heart failure.
To make sure you never miss a story, subscribe to Breaking Science News, the daily newsletter from Technology Networks. Bye.